Okay. So let's begin with what the heck a sequence even is. Okay. Here's a very, very basic, easy to understand definition of a sequence. Okay? It's an infinite list of numbers. And there you go. An infinite list of numbers. Okay.
What you get out of the function?
Yep, and we're actually going to head there. You're thinking ahead, that's good. In general, okay, so in general means we're not going to use specific numbers, we're going to use some abstract here. A sub n is equal to a sub 1, comma, a sub 2, comma, a sub 3, comma, a sub 4. Where a sub 1, a sub 2, a sub 3, a sub 4 just represent the numbers of the sequence. These are all called the terms. The individual numbers of a sequence are called its terms. Okay? So this is a general abstract way of thinking about a sequence. Here is a specific sequence, for example. 2, 4, 6, 8, 10. Dot, dot, dot. What does the dot, dot, dot mean? Keeps going, because what is a sequence? An infinite list of numbers. Okay? Not all sequences have a pattern. This one happens to have a pattern. What is the pattern? Goes up by 2 every time. Okay? This one happens to have a nice pattern that's easy to recognize. Not all of them have a pattern. And those that do have patterns aren't always as easy to recognize. Okay? Now, let's get into a slightly more mathematical definition of a sequence, I guess, rather than just an infinite list of numbers. Okay? So a sequence is a function, and I think this is what, who was sorry? Joe, you were talking about this. A function f whose domain is the set of natural numbers. Now this isn't the whole definition, but let me just explain what this first sentence means. You guys know what domain is, correct? It's the set of all possible x values or inputs, right? Normally with functions, if the domain is all real numbers, you can plug in anything you want. But this domain is the set of all natural numbers, not the set of real numbers. What's the difference? This is just a little bit of number history here. What's a natural number? Well, okay, that's the natural number with quotation. But natural numbers in general are, they're also known as counting numbers. 1, 2, 3, 4, 5. Those are natural numbers. Those are considered natural numbers. Okay. Thank you. So that's the domain of the function. Okay. The terms of the sequence are the function values f of 1, and then f of 2, and then f of 3. Notice how we're only using natural numbers as inputs. Dot, 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 f of n. Okay. More commonly, a sub n is used instead of f of n. For example, I know this sometimes is very hard to decipher the meaning of a mathematical definition. So for example, what are the terms of the sequence defined by f of n is equal to 2n? F of n is equal to 2n. Now, this right here you need to pay attention to. More commonly, a sub n is used instead of f of n. So on your assignment in 12.1, they're not going to write the equation of a sequence in function notation. So this would be more likely written as a sub n equals 2n. A sub n equals 2n is how you're more likely to see that written. So what are the terms of the sequence? First of all, what are the n values? The natural numbers. What's the first natural number? 1. So the first term of this, I want you to write some blank spots here. Comma, and then a blank spot, then a comma, then a blank spot, then a comma. These blank spots represent the terms of the sequence. Yes?
Yes.
Okay. For the first term of the sequence, what's the n value going to be there? N equals 1, right? Now, if n equals 1 and you plug it into the formula, what is the actual first term of the sequence? 2. Okay? Now, for the second term of the sequence, now you're going to have an n value of 2. If n equals 2, what is that second term? 4. Okay? And here, if n equals 3, because that's the third term of the sequence, what are we going to get as a term there? Where are these numbers coming from? The 2 and the 4 and the 6? Well, these numbers here, the n equals 1, n equals 2, n equals 3, those are the natural numbers, but where's the 2 and the 4 and the 6 coming from? The equation of that sequence. The equation is 2 times n, okay? So you have to figure out where your n values are to get that particular term of the sequence. The fourth term is where n would equal 4. If n equals 4, then the actual term there is 8, and then so on, and then so on, and so on. Okay? Another way I think is helpful to visualize this pattern, if this is a function, which it is, we can imagine this using an input-output table where we have n and a sub n values. If n equals 1 and then n equals 2 and then n equals 3 as our inputs, what were the corresponding outputs? If n equals 1, we got 2. If n equals 2, we got 4. If n equals 3, we got 6, and so on and so on. So you can think about these as input-output relationships where the inputs, I guess, correspond to the spot in that sequence. If n equals 1, that's the first spot. If n equals 2, that's the second spot. And these outputs here represent the actual terms of the sequence. Okay? And this is how your homework starts out. Some pretty simple questions like this. Here's example 1. Find the first 4 terms of all of these sequences. So for part A, here's a sequence. I want you to write the first 4 terms. A sub n equals 2n minus 1. Go, quick! Write the first 4 terms of that sequence. When you finish with that one, write the first 4 terms of this sequence. Last part of this example, find the first 4 terms of that sequence. The first 4 terms. Ooh, that's a deep question.
You have to like go infinity minus 4.
You cannot leave this classroom until you write the last 4 terms of each of those sequences.
We have Parker Charrington to attendance for checkout.
Yep. What's tonight? Hey! Yeah, the battle will be legendary. Anybody think they got anywhere on part 8? First 4 terms? Somebody brave. 1, 3, 5, 7. That's absolutely right. 1, 3, 5, 7. Now where do those come from? The first term of a sequence is where n equals 1. So if you plug in an n equals 1 into the formula, 2 times 1 is 2. Then you subtract 1 and you get a 1. Okay. The second spot of a sequence is where n equals 2. If you plug in a 2, 2 times 2 is 4, but subtract 1 to get 3, and so on and so on. What about part B? 0, 3, keep going. 8, 15, okay. That's found the exact same way. The first term of a sequence is where n equals 1. Here's where n equals 2, and so on and so on. Ooh, we get some fractions now. Wonderful. 1/2. 2/3. 3/4. 4/5, and so on and so on and so on. Okay? That's how your homework starts. You just have to list a couple of terms in the sequence. Okay? We okay so far?
Yes. Yeah, this is only like grade math.
Yeah, yeah. Okay, example 2 then. You smarty pants, try this one. Find the nth term. Now, this is the direction that the book also gives, find the nth term. You need to understand what they're asking, so listen carefully. Are you ready? Finding the nth term. Everybody look up here at the screen. Finding the nth term is exactly the opposite of what we just did. I'm going to give you the first 4 terms of a sequence. You've got to recognize the pattern and tell me what the equation would be. That's what it means to find the nth term. Do you understand what I'm asking?
Yes.
Okay. I'm going to give you a couple of terms. You've got to try your best to find some kind of a pattern and then fit an equation to that pattern. It's not always that easy, but it is so fun. So part A, 3, 5, 7, 9, 11. I'll give you a minute here. This is not something that's going to come if you just wait for other people to tell you what the answer is. This takes practice. Do you think you have it? Okay, hold on a second though. Don't say a little bit.
Does it always start at 1?
N always equals 1.
So like, in the list of numbers, then like you listed right there, is it always going to start at 1?
Well, this is where N equals 1.
Okay, so it's
This is where N equals 2. This is where N equals 3. So you've got to come up with some kind of formula where you can plug an N to it and get those values. It's like solving a puzzle. A puzzle that's fun? I'm glad you think so, Gabe. I like that attitude. Here's something to consider if you're having a little bit of trouble. What's the pattern, first of all? They're odd numbers, true. It increases by 2. Now, the key here is it increases by the same number every time. So would you say that it has a constant rate of change? What type of functions has a constant rate of change? Linear. So the equation for this sequence is going to be a linear equation because it has a constant rate of change. What is the constant rate of change? 2. So in a linear equation, how else do we describe the rate of change? The slope. If this is increasing by 2 every time, then don't we have to have a linear equation that has a slope of 2? You following? Okay, Aubrey, you said it. Say it. 2n plus 1. A sub n equals 2n plus 1. Why does it have to be 2n? Because that's the constant rate of change. Okay. Now, why is it the plus 1? Well, if it were just 2n, that would give you the sequence 2, 4, 6, 8, 10, right? These are all 1 above that, so it's got to be 2n plus 1. Now there is, and we're going to learn this in 11 point or 12.2, there are ways to do this other than just thinking and guessing and logically reasoning. For right now, I just want you to practice coming up with these rather than me telling you the formula. Try this one. Okay, 1, 4, 9, 16, 25. Did I not challenge you enough? No? Easy. It's obvious. It might not be obvious to everybody. All right. If you're so smart, what's the formula here? N squared? Is that what we're getting? Always check though. Whenever you think you've come up with something, test it. Okay? If n equals 1 and we plug it into that formula, do we get a 1? If n equals 2 and we plug it in, do we get a 4? And 9 and 16 and 20. All right. Man, oh man, I thought I had you there. Okay, 0. Oh, I can't let the cat out of the bag. I want to write all 4 terms at once.
I feel like we just did this.
Let me give you a hint, especially involving sequences whose terms are fractions. If this were me, I would come up with two separate formulas. One formula that describes the numbers in the numerator, and one formula that would describe the numbers in the denominator. Just come up with separate formulas. So a sub n equals something over something. Don't try to think of it all together. Think of a formula that would give you just the numbers in the numerator, and then think of one that would give you just the numbers in the denominator. For example, what would give us numbers in the denominator? N. What about in the numerator? N minus 1. So the formula is n minus 1 over n. Kind of cool, isn't it? I love sequences. They're so fun.
We should do something with the square root or log root.
That would be awful. Okay, let's go on to objective 2. What's that? That was objective 1. So, no, we're not going to have time to finish this whole thing today. Recursive formula for a sequence. Recursive formula for a sequence. Okay. Oh, I guess I should go over some other. Go back up a step here. Draw an arrow to each of these that you came up with. These are all known as explicit formulas. Because the explicit formula gives you the exact term of the sequence in any spot you want it. Okay? What I mean by that, let me clarify here. Look up here at the screen for a second so you can understand this. This sequence formula that I'm circling right here. You see it? If I wanted the 10th term of that sequence, how would you figure it out? You plug in a 10, you square it, you get 100. If I wanted the 45th term, how would you find that out? You plug in 45 and square it. The explicit formulas will tell you any term you wanted just by plugging in that n value. You follow? The recursive formulas are different. The recursive formula can't tell you any term you want. The recursive formula depends on the term in front of the term you want. So if I want the 10th term, what term do I have to know? The 9th term. And sometimes the 2 terms in front of it. So recursive formulas are defined much, much differently. Okay? The nth term may depend on some or all of the previous terms. Both of these types of formulas have different uses. If you want just random terms of a sequence, and it doesn't matter what order they're in, if I want the 10th term or the 2nd term or the 45th term, the explicit formula is pretty good for that. If you want to quickly generate all the terms of the sequence in order, one after another, recursive formulas do that pretty quickly. Okay? Here's an example of a recursive formula. Example 3. A sub 1 is equal to 2. What does this mean, by the way? A sub 1 is equal to 2. What does that 1 mean, you think? This is the first term. Okay, we know the first term. We know that the sequence starts at 2. Okay, now A sub n plus 1 is equal to A sub n plus 3. This is the recursive part of the formula. Now I want you to label this exactly how I'm labeling this. Okay, this a sub n plus 1, I want you to write that and consider that to be the next term. According to this recursive formula, the next term is equal to a sub n, and I want you to label that as the current term plus 3.
So is this supposed to be like a change in a function? Or a change in a sequence?
You can think about it that way. You can think about it that way, yeah, absolutely. So, if we're listing the terms of the sequence, we already know the first term. The first term is 2. You guys agree? That's our current term right now. The current term that we have, that we know, is 2. According to the recursive formula, what's the next term in the sequence? The next term is equal to the current term, which in our case is 2. And what do you do to it? You add 3. So what's the next term? 5. The next term in the sequence is 5. But now that is our current term. 5 is our current term now. So how do you find the next term? You add 3 to the current term. So what's the next term going to be? 8. But now that's our current term. So what's the next term going to be? 11. That's our current term. So the next term is going to be 14. And then 17. And so on and so on and so on. So a recursive formula is good for generating the terms of a sequence in order. Okay, because in order to get the next term, what do you have to know? The term behind it. Okay? In order to get the ball rolling, you had to know the first term already. So recursive formulas will always give you at least the first term. Because you can't get any next term without knowing the terms in front of it. You follow?
Yeah.
So try this one. Right, so part B. Write the first 5 terms. A sub 1 is equal to 6. A sub n plus 1 is equal to a sub n plus 4. There's your recursive formula. A sub 1 is equal to 6. A sub n plus 1 is a sub n plus 4. Write the first 5 terms of that recursively defined sequence. Recursive formulas are a great way to quickly generate terms of a sequence in order. This tells you exactly what to do to generate each next term. Yeah?
What's the n plus 1?
Well, a sub n is a term of the sequence, right? A sub n. So a sub n plus 1 means the term that comes right after a sub n. Okay?
So if it's like plus 2, then would be
That would be,
third.
and then the third, yeah. Okay. Now, so the first term is 6, because that's what we've been told. What's the next term? 10, because you add 4. And now the next term is 14, and then 18, and then 22, and so on and so on and so on. Okay? Now, I want to clarify something here real quick. The bell's going to ring in just about a minute. I use this notation because I think it's easier to understand. A lot of textbooks use this notation. Our particular textbook uses this notation, slightly different. Okay? A sub 1 is equal to 6. It still starts the same way. A sub 1 is equal to 6.
So can we scroll
Okay.
this off?
You can use whichever one you want, really. The book that we're using would say this. A sub n is equal to a sub n minus 1 plus 4.
I guess both.
The current term is the previous term plus 4.
The current term that you're searching for, so they're considering it this way. The term that you want to find is the term in front of it plus 4. That's what they're talking about with this formula. For example, if the first term is 6, aren't we searching for the next term after that, which would be a sub n? This is a sub n. So they're saying to find a sub n, you go to a sub n minus 1, which is the term in front of it. So if you go to the term in front of it, that's 6. If you add 4, you get 10. Different way of describing the same thing.